we're looking more at parabolas here. And when we looked at parabolas at the beginning of the last lesson, we looked at the graphs and identifying the different points, the vertices, whether they open up or down, some of the intercepts. And in doing that, we notice that the vertex is really one of the most important parts of the parabolas. It tells us the minimum or the maximum value. It also identifies kind of the center of the parabola where everything is going to be symmetric, so it tells us what the axis of symmetry is. And we looked at how to graph the parabolas, but we were always kind of given the vertex. We knew that it started at 0 and we were able to find that. But if you look at these two graphs, the vertex is not at 0. And when I mean at 0, I'm talking about the x-coordinate. So what we're going to look at today is what happens when the parabola shifts left or right. How do I identify where that vertex is so I can identify the other points on the left or the right of it to figure out where the parabola is going to be. So the nice thing about these examples, and these were actually in the last video as well, is they show us the equations of the parabola and they give us the vertex. And once again, here's the equation of the parabola and there is the vertex. And if you study those for a little bit, you're going to start to notice that there is a coincidence, but it's really not a coincidence between the numbers you see in these equations and what the vertex is. You see a 2 right here, and you see a 2 as the x-coordinate. You see a 1, and that turns out to be the y-coordinate. You see the 3 here, that's the x-coordinate, and you see the 4 as the y-coordinate. The only difference is the x is the opposite. So I see kind of like a -2 here, and that turns into a +2. The y stays the same. We got a +1 or +1, that's still +1. When I look in the equation here, I have a +3, that turns into a -3, the +4 stays a +4. So this form of equation, and parabolas come from quadratic equations, so this form of the quadratic equation is called the vertex form, which I'm going to show you up here. So the vertex form looks something like this. All right, so there might be a number outside of the parentheses there, in this case the a. But if you subtract something from the x within the parentheses and then have a constant outside in terms of k, the vertex is always going to be hk. And this is the most simple way to identify the vertex because it's literally what is subtracted from x is your x-coordinate, and what is the constant by itself is the y-coordinate. So just using that idea, looking at the examples, looking at this first example here, the number being subtracted from x is 3. So that vertex is going to be 3, and then we have the constant of 7. So that vertex is 3, 7. The next one, it's slightly different because you notice in the vertex form, we have a number being subtracted from h. But in this case, it's being added. So what we kind of have to think of is this is really x minus -5, which means the x-coordinate is -5, and then the y-coordinate is 8. And the last example, same idea. It's x plus 3, so the x-coordinate has to be -3. And then the y is negative as well, so that's just going to be -9. So that's how you find the vertex. It's a very simple, straightforward process when you have vertex forms of quadratics. However, you don't always get it in that form. In fact, it's kind of rare to have it in that form. Standard means normal, and the normal way that you typically will see a quadratic is in the standard form, where you get y equals ax squared plus bx plus c, where a, b, and c could be the constants. So you kind of see the examples down here. 2x squared plus 8x minus 9, or x squared minus 7x plus 10. Those are examples of quadratics in standard form, and you can see what the a, b, and c turn into. Just like all equations that can be graphed, y and x just stay y and x, because those represent all of the points that are going to be on there. And I just realized I forgot to put all of the y's in there. Not a big deal. We'll just pretend that those y's were there all along. kind of insignificant for what we were doing, so not a huge deal. All right, so to find the vertex when you have a standard form of a quadratic, it's actually a lot more difficult than the vertex. You have to remember kind of a little formula, negative b over 2a. And in this situation, this is only going to give you the x coordinate. When we had it in vertex form, it gave you the x and the y, and it was very straightforward, very simple. Here you only get the x coordinate, and you would have to use the formula itself to figure out what the y is. So let's take a look here. For negative b over 2a, the first thing that you have to recognize is the coefficient of the x squared is the a. So for this particular example, a is going to be 2, and then b is going to be x, as b is the coefficient for the x. Notice c doesn't come into this at all. And the c, if you remember from the other parts, the c just shifts the parabola up and down. So since we're dealing with just the x coordinate here, there is no left or right movement from that c, so that's why it's not part of the formula to find the x coordinate. Now obviously it's going to matter where the y coordinate, but that will come in later. So what we're looking at for negative b over 2a, we have negative 8 over 2 times our a, which is 2. So this is negative 8 over 4, which gives us negative 2. Now remember, that is only the x coordinate. All right, so that's our x coordinate, so we have to use that to figure out what the y is going to be. So we're going to need to put that into the equation. So y equals 2, and instead of x squared, we're going to put negative 2 in there, plus 8 times negative 2 minus 9. You could use a calculator here if you wanted to, or we can just go through the math. Negative 2 squared is 4, plus negative 16 and minus 9. So we've got 8 minus 16 minus 9, which is going to end up being negative 17. So the vertex for this particular problem is going to be negative 2 for our x and negative 17 for the y. Now there's another example down here that we can go through. Let me get rid of this so we have some room. Bring back my drawing tools. Okay, so once again, we're looking at negative b over 2a. So this case, we have to notice that there's no coefficient of the x squared, which is okay. That just means a equals 1. The other thing that we have to recognize is it's minus 7x. So b is negative 7. So when we're looking at negative b over 2a, negative 7 is really positive 7. And 2 times 1 is just 2. So we have 7/2 as our x coordinate. So this is going to get a little sloppy, but not a big deal. So we have our x coordinate. Now we need to find our y coordinate. So y is going to be 7/2 squared minus 7 times 7/2 plus 10. So 7/2 squared, we just square both of these. 49 over 4. And we have negative 49 over 2 plus 10. With the fractions, we need to get common denominators, so we can leave the 49 over 4 and change this to 98 over 4. And just to make everything with a common denominator, I'm going to put that as 40 over 4. And that's going to give us 49 minus 98 is negative 49 plus 40 over 4. So negative, need some more space, negative 9/4 is going to be our y. So our x was 7/2, and our y was -9/4. Now, fortunately, I don't think your assignments are going to have any fractional values. I think you're going to deal with all integers because you're going to be plotting these again. So if you remember the last assignment, you started with a vertex, and then you found 2 points to the left and 2 points to the right, and then you used the parabola tool to graph them. That's what we're doing here. We're trying to identify where the vertex is so we can find 2 points to the left and to the right to plot them. So I'm going to pull up some Alex problems and show you how we're going to do that based on what type of equation we're given, whether it is the vertex form or the standard form. So taking a look at the problems that you're going to see on Alex, the first thing I notice is that this is in that vertex form. So it's going to be super easy to identify the vertex because we're looking at x minus h squared plus k, and this is exactly in that form where hk is the vertex. So what is being subtracted from x is the x coordinate. In this case, it's 5. And the k, the constant by itself, is the y coordinate. So 5 is the x coordinate, and 1 is the y coordinate. So 5, 1 is the vertex. And that is, as mentioned, pretty much the most important part. You see, we have to plot 5 points in order to use the parabola tool. We need the vertex. We need 2 points to the left of the vertex and 2 points to the right of the vertex. So we have found that. So if I'm going to make a table to get all of these, I have 5, 1 for the vertex, and then to the left I have 4 and 3, to the right I have 6 and 7, and if you remember, everything is symmetric, so I don't need to find all 4 of these points. I can find 2 of them and get the other 2. So I'm going to go with these 2 points because I'd rather use the smaller numbers. It's a little bit easier to do math. So I'm going to start off with 3. So we're going back up to our equation. Instead of x, I'm going to put 3 in for x. So 3 minus 5 squared plus 1 gives us -2 squared. And -2 squared is 4. So 4 plus 1 gives us 5. So we have the 0.35. And that's going to match up with the 7. So we can go ahead and just put a 5 down there for the 7. And then change colors so we can see the difference. We're going to do the same exact thing, but with 4. 4 minus 5 is -1. -1 squared is 1. So 1 plus 1 equals 2. So we'll have 2 here. Now I'm going to go ahead and I'm going to write these down because I cannot keep them up on the screen while I use Alex. So I'm going to have to delete all of these points, but I can now put these in. So our vertex was at 5, 1 right there. We had another point at 4, 2 and at 6, 2, and then we had 3, 5 and also 7, 5 for that symmetrical look. And then we go ahead and use our parabola tool and it puts it there for us. All right, so let's find another type of question. Let me go to question 6 here. Just going through this briefly, this is also in vertex form. It's slightly different because it has an A outside, so it's not too different, but just slightly different. So let's go ahead and look at, first of all, the vertex. So remember, we're looking at what is being subtracted from the x, and in this case it's -3 because we see the plus sign there. So -3 is going to be our x coordinate and -4 is going to be the y. So our vertex is -3, -4. So a little different because we're on the negative side. And when we're on the negative side, remember to the left, we're going to have -4 and -5. They get a little bit larger. And then to the right, -2, -1. So I'm going to go after the -2 and -1 because it's going to be a little bit easier to use. So let's go ahead and go back to our equation. Y equals 2 times x plus 3. I'm going to start with the -2 plus 3, which is 1. And 1 squared is 1. And we're really just following order of operations here. So 2 minus 4 gives us -2. So for our -2, we have -2 for the y, for the -2 and -4 versions of the x. Now let's do this same process when we put -1 in for x. So inside of the parentheses, we get 2. Next are the exponents. We get 4. Next is the multiplication, and then the subtraction. So we end up with 4 here. And once again, I'm going to go ahead and write this down. I know you guys can't see this off screen. No big deal. But I just need to see these. I can't memorize all of these in my head. And let's go ahead and graph them. So starting with the vertex once again, that was at -3, -4. So we'll put that point there. And then -2, -2, and getting our symmetry here, we also have that for -4. And then -1 was all the way up at 4. And our -5 was also all the way up at 4. And go ahead and plot our parabola. Now, when you get something like this, something went wrong, and I can see right away what it is. I messed up this point. That was not at -1. Now it's at -1. Now it looks much better. All right. Let's move on to one that's in standard form. So here we have x squared plus 8x plus 18. So once again, we need to identify the vertex. It is going to be a lot more difficult to identify the vertex when it's in standard form, but you need to just remember -b over, oops, sorry about that, -b over 2a to find the x value of the vertex. So in this case, there is no coefficient in front of the x, so that means a equals 1. The coefficient, in front of the x squared, so a equals 1. In front of the x, it's 8. So we're looking at -8 over 2 times 1, which is -4. So we can go ahead and look at our x and our y. -4 is going to be the vertex. Now we're going to have to figure out all of these. So we have -5 and -6 to the left, -3 and -2 to the right. Obviously we need to find -4. So now I'm going to do this. We're going to have to do it 3 times. I'm going to look at these because once again I want to deal with the smaller numbers here. So let's start with the vertex. So we've got y equals -4 squared plus 8 times -4 plus 18. And going through the order of operations, negative 4 squared is 16. And then we have minus 32 plus 18. Here's a little trick. Both of these are positive. So some people like to go ahead and add those together first. So that's 34. And then we subtract that 32 because it's kind of the negative number. So we end up with 2. So our vertex is at negative 4, 2. Let's go ahead and do the next problem, where we're going to substitute negative 3 in 4x. Negative 3 squared is 9. And then we have negative 24 plus 18. Adding those positives together once again, we get 27. And 27 minus 24 is 3. And the last one, y equals negative 2 squared plus 8 times negative 2 plus 18. So negative 2 squared we have 4 minus 16 plus 18. So we have 22 minus 16 gives us 6. And just continuing on with our symmetry, here are the points we end up with. And I'm going to go ahead, once again, need to write these down so I can put them onto the graph. And I'll go ahead and plot those points. Vertex was negative 4, 2. And then we had negative 3, 3, and also negative 5, 3. And then at negative 2, we went all the way up to 6. And also over to 6 at negative 6. And put our parabola in there. And one thing I also want to mention, remember, parabolas are not linear in any sense of the form. If you're trying to look at slopes of these things, if I look at the slope of these 2 points, all right, that slope is 1. But then when I look at the slope between these 2 points, that has a slope of 3. And if I went even farther, the slope would keep increasing, which is why it's not linear, which is why we get that parabola. So if you find yourself graphing and it keeps going up 1 over 1, up 1 over 1, you've done something wrong with your parabola. So be careful with that. So I'm going to go ahead and check this work here. We're going to do one more before I let you go. I want to find one that's in standard form but has a coefficient in front of the x squared here, like this one. That's perfect. All right. So once again, we need to identify the vertex. If I've said vertex a lot during this lesson, it's on purpose. It is that important. So with the vertex here, once again, we're looking at negative b over 2a. We have we have a coefficient of the x squared this time, which is negative 2. And b is also a negative coefficient. So when we look at negative b, we're looking at negative 16, which is going to obviously turn into positive 16. And then 2 times negative 2 is negative 4. So our x-coordinate for our vertex is negative 4, just like the last problem. All right, so using that negative 4, we need to come up with our table of values. And I'm once again going to focus on the ones with the smaller values because the math is just easier that way. So starting with the vertex and going back to our equation, y equals negative 2 times negative 4 squared minus 16 times negative 4 minus 34. Got some larger numbers to deal with here. So we've got Negative 2 times 16. Negative 16 times 4. Little trick to multiply by 4, double it twice. So you double 16, you get 32. Double 32, you get 64. So we've got minus 64 there, minus 34. And all of these end up being negative numbers here. So it's really just adding them all up. So this gives me negative 96. And when I'm looking at this, something is not right. Where did my error occur here? That's where it occurred. Sloppy handwriting. That negative 16 times negative 4 should have been positive 64. I can go back real quick and fix that. So now, let's go back to that old trick. Let's add the negatives together. So that's negative 66 plus 64 equals negative 2. That makes a lot more sense since the graph is only going up to 14. Can't be into the negative hundreds. So we got negative 2 for our vertex. Try to find a little bit more room to go to the next one. Try not to make that same mistake. So negative 2 times negative 3 squared minus 16 times negative 3. Making sure I have the negative this time that I can see. So we've got 9, and negative 2 times 9 is negative 18. Plus, this time, because a negative times a negative gives us that positive. So plus 48 minus 34. We're going to go ahead and add these two together. So that gives us negative 52 plus 48. That gives us negative 4. We're going to need to clear up some space. I wish my eraser was a little bit larger than the tip of my finger. That would be fantastic. All right, so let's go to that next, or our last coordinate here. So negative 2 times negative 2 squared minus 16 times negative 2 minus 34. So negative 2 squared is 4 times negative 2 gives us that negative 8 plus 32 minus 34. So we've got our negatives adding together to give me negative 42 plus 32 gives us negative 10. And I'm going to copy those down so we can graph them appropriately. And while I'm doing that, you notice this problem is going to look a little bit different because of that negative coefficient on the x squared. That means it's going to open down for us. So as we plot the vertex at negative 4, negative 2, the points are going to be going downward instead of upward this time. And that's what we have. So we talked briefly about, we didn't get in depth, but when the graph opens upward, that means the A is positive when it's in standard form, or even vertex form. And when it's negative, which we have in this case, the parabola is going to open downward. Check this to just ensure that we are right. Luckily, I caught my mistake before I put it in there. And we are good to go. So your assignment this week obviously is going to be on Alex. It is called More Parabolas. We had intro to parabolas earlier this week, so we're going more in depth into parabolas. And as you can see, it's 10 questions worth 10 points. And I will be around in the Zoom sessions if you need any assistance. Good luck.